Hi, my name is Michael Chow, and in this screencast I'll be doing a live translation in Python of analysis that was done in R as part of a project called Tidy Tuesday. I'm doing this to show what analyses look like in different languages and compare approaches that people may take in one versus the other. If you haven't seen, so Tidy Tuesday is a project started in the R community where people get together and every week they do an analysis on a new data set. One really interesting thing is a data scientist named Dave Robinson has done hour-long screencasts of all his analyses and put his code online. So as part of that, I'll be translating his code into Python so we can see what it looks like to go from one language to the other. I'm also doing it as part of my development on the data analysis library siuba, which is a library designed to make data analysis a lot easier. You may have noticed last week there were a couple snags I hit in siuba. In the week since then, I've actually fixed them and pushed the changes to PyPy. So let's go ahead and get started. I'll be doing it this week on a dataset that was released last March on women in the workplace. I've pulled the notebook from Dave's repo that's here, women in the workplace. I'm going to go ahead and open it in JupyText so I can click the notebook. JupyText is a really nice tool that lets you open documents that are written in Markdown or this special format called R Markdown. So it's handy for going from one to the other. Let's see. Sorry, let me just get started. I'm going to go ahead and run this in R. Oh, wait, I keep forgetting. I need to load R. I'm going to grab that snippet of code from last week's analysis. One of these days, I'm just going to keep it at the ready. So I think that's this, or I'm surprised. Oh, here. So, all right, we want this piece of code. All right. And you have to forgive me if I cough or anything. I'm a little bit under the weather. So, all right. We have RPy2 loaded. This lets us run R in our notebooks since our notebooks are running Python. So here we're able to read the data. It looks like it's 3 data sets: job, gender, earnings, female, employer, gender. I'm going to go to the Tidy Tuesday repo really quickly just to look and see what we're dealing with here. All right, so there's a lot of really useful context, and the person I think who gave some useful recommendations. Looks like this is the data that was copied in into our script, and then there are some useful data dictionaries for the 3 CSVs. So this is jobs by gender. It looks like by year, occupation, major and minor category, and then earnings, female, employed, gender. I think this is similar. I think there's a similar analysis on US PhDs that looked at gender also in the data. And this comes from the Census Bureau. All right, so I've got the data pulled up. I'm going to focus mostly on doing a straight translation of a lot of the analyses and trying to reproduce the plot. So I won't focus too much on the substantive content of the subject area domain. All right, so I'm going to look at I'm going to hide this. Let's just go ahead and try running some of this. This is interesting. So there's a function here that will be doing some processing on the data. I'm guessing the 3 data sets. Where is it? Summarize. Yeah, here. So it looks like it gets used periodically. We can dig more into that in a second. Just going to go ahead and make sure it runs. I should probably do that actually before the screencast. Okay, great. So now what I'm going to do is I'm going to make a copy of it. So I'll right click and duplicate. Then I'm going to rename this just to have siuba at the end. And then I'm going to go ahead and open it also in JupiText. Okay, so this is the old analysis from last week. Here's a README with links to the original code. Let's see. All right, I'm going to move this. I'm going to move this into a split screen. Great. So let's go ahead and import pandas. And do from siuba import. And as I use things from siuba, I'll go ahead and import them. This is tidyverse scales, so this is a classic set of R function, really common set of R functions for data analysis. This is often used for plotting. Usually uses it to convert labels to percentages. All right, so I'm going to go ahead and get rid of that. And here I'm just going to use pd.readcsv. Let's see, should be okay. Both readr and pandas do, I would say, a really good job of reading CSVs and handling a whole range of cases. Oh, that's the arrow. Obviously don't want that. Okay. Yeah, so it just read in, no problem. One thing I can do is use show grid to look at, for example, some of the data. A common thing is wanting to toggle, I think it's display full width. Let's see. I'm constantly looking this up. Force fit columns. So we want to set grid options, force fit columns to false. So force fit columns false. Right. And notice that just lets us pan over rather than jamming everything in. Okay, so I'm going to take a look. Occupation, major category, minor category, total workers, workers male, workers female, percent female, total earnings. Okay, yeah, great. And okay, so I'm going to go ahead and just comment that out. Let's try to do just the first few plots and then go back and see maybe how this is being used more broadly. So I'm going to comment, well, we'll need it here. What's the best way to do this? Well, let me start with everything leading up to it, and then we can figure it out. So I'm going to comment this out. I'm going to move these, move this one off because it's a separate plot, so we can show all our plots in the same place. Going to do that here also. Okay, and then so this is the data we have. Change this to the equal sign. Use parentheses, and then yeah, that's fine. And then in siuba we use this two greater than signs for our pipe. Oh shoot. Okay, so the complete cases is this is when there are no missing values in a row. So I'll actually have to think of what the data frame method is. I haven't used it in a while. I definitely know there is one. I think it's well, let me take a quick look. So jobs gender dot sometimes autocomplete takes a little bit. So is it I think nope. I'm gonna Google it. So pandas drop keep only complete rows. Complete rows. Oh, drop NA, and you can use it at the data frame level. Notice that there's this how argument. Any will want it. That's the exact same as complete cases. So complete cases flags when a row is missing any NA. It marks it as false. So what's happening here is complete cases saying it's only true if the row doesn't have any NAs in it. So what we can do here is we can do dot drop NA. I realize this isn't the most appealing syntax. It's something I've thought about with siuba. So drop NA, that does it. We don't even need the filter. And then we can group by. One thing we can actually do is rather than using siuba, we can actually use the pandas group by. siuba just takes a data frame or a group data frame. So it's not really a big issue to just use pure pandas. If anything, it's kind of nice. So there, I'm actually just going to use the backslash to move this chain to a new line. And let's make sure this runs. Great. Let's see. So by year major category dot shape. Okay, that's not good. Oh, it's a grouped. Sorry. We do object dot shape. That just gets the data frame out of the grouped data frame. So it's 1242. Jobs gender dot shape is 2000. So it dropped quite a bit. So one thing we could do, one nice thing about something like complete cases for what Dave's doing is actually if you flag complete cases, you can always flip it. So not complete cases to look at the data that would be excluded. And that's one challenge is with drop NA, we don't get that. I'm curious if we can, how to flag it. Probably is NA actually. So is there a way for us though we might have to do is NA if we wanted to flag it per row, do is NA and then do a sum across all the rows. Let's see. So yeah, I bet that what we could do if we wanted to do something like complete cases is we could do let's try this out. Jobs gender dot is NA. So notice that does it all here, and then we do any. I think this will by default do it down the column, so we'll get one result per column. But what we can do is I think we can change axis to be 1, and now notice we get a result per row. We can do this with the way this might work with siuba is we could do, instead of drop NA then, we could do filter, use the underscore to represent our data. So where use this basically to filter the data. Let's see. And then let's switch back to the so we could still do this, but let's switch to use the siuba group by siuba filter. Yeah, so this should be, oops, my bad. So just change this. I'm gonna put these back in quotes just because, oops. Okay, great. Oh no, I've done something terribly wrong. Yeah, it would be nice, actually, maybe, oops. Let's see. Oh, I need to, so I need to run this. So, okay, I've done a terrible thing. Let me switch this. All right. So the big benefit of this syntax is we can then say, oh, you know what? Let's see everything. Let's actually see. So if we did not is NA, it's equivalent to complete cases. I'm going to move this here. I should have kept the old code. Actually, it'll be quick to write. But so just to show what this might look like. So notice this one's only keeping the complete cases. This row is all the filled in data. The one big benefit of this syntax is we can say, oh, you know what, show me actually the opposite of that. Show me rows we removed. And notice what he was taking out were this column, wage percent of male, in the census data was missing. So that's actually one really handy thing about being able to put together things like filter and isNA flagging complete cases. Okay, so let's keep going. Did I delete? I'm pretty sure there was a summarize jobs by gender here. So let's try this. So we basically do the same thing. Let's def summarize jobs by gender, table, colon. I'm gonna delete this, closing bracket. Yeah, so it's piped. We can do the same. So tibble pipe to summarize has to be in a again here, or we could use the backslash to escape it, which is pretty classic. All right, I'm gonna do. Oh, you know what? I'm gonna prototype this by first doing it. This is a really big chunk of code. I doubt he moved it into this function to start out. That would be pretty gnarly to test. What I'm going to do is I'm going to test it in this group by first. And that'll be a little easier to develop, I think. So this is pretty straightforward. What I do is I'll move it to be methods. So dot sum. No, I'm sorry. This is the sums across this whole thing. So rather we'll do something like this. Dot sum underscore having a good time dot sum. Okay, so this is getting a proportion, it looks like. Total earnings times total workers divided by. That doesn't seem like total earnings, but let's keep moving and see what happens. Maybe total earnings per worker. Yeah, let me go back to that. Let me make sure this runs, and then I'll think a little more closely. He had to remove NAs. The one trick is in pandas, it's fine. You can have NAs by default. It'll remove them. Wait, this is. Oh, I know what's happening. Oh goodness. Okay, so there's a giant. No. Oh, okay. Yeah. So, this is a division going on here. This is a really big division operation going on, and then this is the end. And the reason this is happening is Dave's moving pretty quickly, so it's not surprising that he would be kind of jamming things on a line. He's really optimizing for speed. So we can do something like this: dot sum workers male not is NA total earnings male. We'll just flip it here. Dot not NA. This should be okay. I'm going to comment out the other lines. Notice I'm format a bit. Notice I'm leaving. Yeah, we could just toss this in. This doesn't hurt us. Notice I'm leaving in. I could leave in a comma here. It wouldn't be a problem. But we have bigger issues. Oh, I have to import summarize. Should really do these up front. Total workers. So we didn't escape some things. This is one thing I like about using the underscore, is just that it helps me keep track of syntax and things like that. So total workers female. All right, we're there. So cool. So I'm going to do some black formatting. Notice this is kind of a funny way to format. It's hard to know, actually, in situations like this, the best way to format these kinds of equations. I would probably indent a little bit so that it's clear, but it's actually like just in such a compact form like this, it's hard to represent. So let's see. Total earnings is probably spilling onto the next line. Yeah, I wonder if there's a cleaner way. Let's see, so again, with the NA remove, it doesn't matter for our case. So dot sum divided by a similar situation. I think there's a lot of repetition going on. I should have looked a little more carefully before I started deleting things. So this is the sum where total earnings isn't NA, basically. Wait, well, if we're only keeping complete cases, I don't think this matters, but maybe there's a case where he uses it without filtering. It looks like maybe down here. So basically what I'm pointing out is here he takes a lot of care to filter cases with NAs. But if we're doing it here in the filter, it shouldn't be an issue. The reason he's doing it, I think, is so he can use it in other places. Let's just keep going. So great. And this is pretty simple. Pandas itself actually has some pretty simple ways to do these aggregations in cases where you want to give something the same name, like workers mail equals workers mail dot sum. You can use the dot ag function. Where it's useful is where he's doing things like this, where you're using multiple columns together. That's not something the ag can easily handle. All right, so let's just see what happens. Okay, should have known. I didn't even try. Great, let's do this. There are probably some more convenient ways to represent this, like maybe gathering the data into a longer format or something. I'd have to think about it a little more carefully. All right, so anyways, the net result is per year, per major category, you have these new columns: total earnings male, total earnings female, total workers male, workers female. So let's make sure that and then I think there was a mutate, one more column, which is wage percent of male is total earnings female divided by total earnings male. Oh, gotta import mutate. Oh, what happened? Oh, okay, my bad, not mutat. Not yet, so cool. And then, all right, so it's probably just about ready to move back in, but let's, just to double check while we're here, this is a really nice format for testing, so let's make the plot just for sanity, and then we can always move this back into a function then. So by year major category equals this, and then we're gonna make a plot. Oh, I need to import from plot9. So from plot9 import star. This is convenient. Plot9 has a ton of functions. It's a really cool plotting package. It basically implements this package, ggplot, in Python. So we're gonna surround you. Can I do this? Oh, that's convenient. So I just highlighted all the text and I pressed open parentheses and it surrounded it automatically. So what I'm going to do now is quickly switch to the mutate. All right, ggplot. The big difference for plot9 is you need to put them in strings. You can actually also do that. So you can highlight it and then press quote and it will put the quotes around it. This is fine. I'm going to move the plus down here. I think actually if I black format, it'll do it automatically. Expand limits looks okay. So, factory order. The nice thing is siuba actually implements this function, so let me show you it without FCT reorder and then with. So the key is that this is a little hard to see. Notice his levels are in a different order. His levels basically correspond to what you see on the plot. So his top level is this one. His second to top is the second highest. Notice ours aren't. So we have education, but education's down here. And how he did that was FCT reorder. Basically, he reordered the levels, I think, according to the median total earnings, which is our y-axis. This is really convenient because it lines everything up for people. It makes it really easy to spot. So I'm going to import FCT reorder from siuba. I'll just do it up here. From siuba.dpy.forcats. Forcats is the name of the R package that has FCT reorder. Import FCT reorder. Okay, so cool. Now notice that it is lined up. Oh, not quite. So this actually doesn't match his plot. Oh, does he have, let's see what's happening. So year total earnings, major category, okay. 0.8. So I'm guessing that I did a division wrong. Let me go back and see some. So the sum of this divided by the sum of total workers. And again, sum of these two divided by sum of total workers. So that's not a good sign. Can we quickly figure it out? I wish I had a good answer for that. So, oh wait, this is a different plot. Oh, I need to rerun this. Okay, sorry, he had two plots, and I moved it to a new cell. All right, so, well, we're not out of the woods yet, but in fact, I'm only more confused. So, let's see. There's computer engineering. It does not seem to be doing the same things. He kept complete cases. We kept complete cases. Oh, no, we didn't. We kept incomplete cases. We did a bad thing. So this is it. It's a little bit hard to see, I think, in the two plots. Oh no, they're not quite right. So they're getting there. I might dump these data frames and see where we're different. Maybe if it's squished a lot. I'm trying to figure out if it's the coloring alone. Normally I can just tell by glancing at the plot if they mostly match. But it's a little bit hard to say here. So, what I'm going to do is I'm going to pull out healthcare practitioners from here. So, let's do that. By year, major, category, filter. I'm going to load a package called stringr. We'll just do it here for now. Stringr just has some nice helper functions for string matching. So string detect it takes the data first. Major category, healthcare, prac. That should get it, I think, probably. Nope, oh, no, that's not. Health cars. Okay, so let's look again. Healthcare, comma. Oh, no. Sorry, no comma. It's dumb of me. So, healthcare. Cool, I need to ungroup it so we can read it a little easier. Usually in the R console, it shows up a little... Okay, great. Oh, it only has 4 years? Is that true? I guess so. So, double check. 2013, 13, 14, 15, 16. Great. So that'll at least make it easy to check. I'm gonna, in this new cell, quickly do filter. I'm just gonna put it here. Dot major category dot starts with healthcare pract. What did I do? I didn't close it. Nope. Let me see what I need to look a little more closely. Oh, I need to use the string accessor, so that lets me use all these string methods, like starts with. All right, so maybe we can just do a quick glance. 76434, 75201, 76906, 78612. You know, I think that it's there. I think it might be worth taking a closer look at the data, but I think these plots seem to roughly coincide. I couldn't tell you why, though, these are not quite lined up. Let me try passing in just to double check. I want to make sure. So factory order in R uses the median of, for example, like total earnings to reorder these columns. So this one, healthcare, has the highest median. That's why it's the highest on the legend. I'm going to check by passing in np.median to R function and see if that does it. No, I'm not sure. So maybe it's close. Maybe it's a near tie. I couldn't tell you actually why these colors aren't the same. Normally, Plot9's really good about. Oh no, this wouldn't be a Plot9 thing. There must be a very subtle thing in the medians. We can, we could check that. So we could do. Is it worth checking though? I think it's so close that it's maybe worth shelving for now and then returning to if we have time. Because if we have some time left over, I'd like to dig into a little more of pandas code kind of behind some of these translations. All right, so let's just go to the next. Let me make sure this is where we want it. I'm going to take this out because we don't need it. Cool. So that's the first. Let's see. So this is the second plot. Ooh. What did I do? Oh, need the R cell magic. So it knows to run R. And then I'm going to put this in quotes. You may notice, actually, if you watch from screencast to screencast, I'm getting a little bit faster, I think, at some of these repeated actions, which is really useful for me. It's good for me to see also a lot of the common actions I'm performing and think about how to speed up the most common things I end up doing here. So wage percent of male, major category, geom_line. Great, let's run it. Nice. So it seems to match. I wish this plot's dimensions are so compressed. Obviously, it looks quite a bit different, but the gross pattern seems to be the same. The order of the legend in this case is basically the same. Again, there's this slight difference, but on the whole, looks pretty accurate. So I black formatted it. Notice that actually what it does in this case is it puts geom_line on the same line, and that's because it doesn't quite reach the 80, 90 character limit for putting things on new lines. I'm going to move it down though, just so we can see it easily. I'm going to do the formatting here. We'll see. Notice it shifts everything back in. That's, I mean, for getting this nice, at least to this point for formatting, that's not a bad deal from black. So, great. Let's go to the next. I could also, I could maybe do some reading into this. Wage percent of male in different areas. So you look at computer, engineering, and science. Wage percent of male was calculated as here, total earnings female divided by total earnings male. So I think this is probably, as far as I can tell, the calculation is average per worker. Yes, average earning per worker. And then he's asking, what's the difference? So, so in this plot, females are making, double check, total earnings female divided total earnings male. So females are making 80%, what males are making in computer engineering and science, or a little more than that. One thing I could do is I should maybe expand limits. So we have y equals, I think I can do this. Notice I just expanded the y-axis to include 0 and 1, just so we can see in full context. Some other things we could do is we could improve these ticks so we can read these differences a little bit better. I'm going to comment this out though, so it's a faithful translation. All right. Excuse me. So by minor category, this is just a calculation. I'm going to move these into the same cell. Oh, that's not helpful. So I bet if we give it the full page, that'll do a lot better. Nope. I need to find a way to widen the plot. I'm gonna have to Google it. Let me see. Jupyter rpy2 plot width. Oh, maybe not the R. So the R kernels, it could be a different thing. Yeah, so this is a different thing altogether than running rpy2. Let me make sure we're looking at the same. It's hard to say, so we could try, it's not looking great for us. We could make some of these smaller. I could also, for now, maybe hide the legend. Let me Google a little bit more. rpy2, I'm going to just go to rpy2 plot width. This seems promising. Oh boy, so, oh, monkey patching, that's never a good sign. Oh, we can change maybe change the plotting device in R itself. This doesn't look like it works though, so but the answer is amended, so yeah, I'm gonna try this. So, oh wow, okay. Let's just give it a shot. Let's see what happens here. I'm a little bit scared because I'm definitely moving fast, like just chucking this in. Try to widen our plot. This is definitely something I'll look up for next time though, because it's something I really want to be able to do. Ooh, that didn't work. Can we try? Let's try making it very large. Nope. All right, so we're in trouble. One thing I could do is I'm going to jump to, do I have Tidy Tuesday Pi? No, I'm going to need to, well, I can just go. So I'm going to go to the directory, repo, Tidy Tuesday Pi. I'm just going to switch to R for now. So one thing I can do here is in R, I can press Control period, and then 2019-03, let's see. Nope, hates me. 2019-03. It doesn't want me to get there, so let's just click. I think if I did write, yeah, it doesn't seem to be searching in the way I was expecting, but I can open it here. So I'm gonna run it down to take this out. One thing to note is, so if I save it here, I'm gonna delete it in the notebook. I'm gonna treat the notebook as law. So notice here it updated, actually deleted the code in our markdown. That's because Jupytex syncs it. Since this is the file Jupytex is using. Get rid of these. I pressed Command-Shift-C to comment out in RStudio. Let's get this going. So fingers crossed. Oh, I don't want the output. I'm going to take the output out. So chunk output in console. That means normally it tries to print it under each of these chunks. I just want to keep it printed out down here and print the plots over here. So let's see, chord flip. Great. Wow, it's taking a bit. Where is the plot? Huh. Yeah, I'm not sure. That's a new one. Normally it's not an issue at all. I think because it's so wide. Yeah, maybe it's a really intense plot. I'm not sure what's going on. I'd have to look more. But this is this is the same plot from before, wage percent per male. Now, rather than being over time, it looks like it's grouped per category for 2016. So I'm gonna, since this is hard to see, I'm gonna use this as a reference. So this is ranking also. So I'm guessing he's used FCT reorder here so that it's easy to see which ones have the biggest disparities. It looks like it's healthcare practitioners and legal. All right, so let's try to translate this. I'm gonna do the classic highlight and then press open parentheses. Gonna shift this here. And what I could do is just maybe this and then do black formatting. It should format. Yep, nice. And then when years 2016, group by major category, minor category, summarize jobs gender. Okay, so this is where we will both. I need to import the ungroup. Nice. And then now I need to define this. What I'm going to do is I'm just going to pull this out. I'm going to uncomment this, and then I'm going to paste this into here. Great, and then I'll just put Tibble here. I obviously need the quote still, so I could do something funky and quote it like this. That's probably not great practice. Here we are. So one thing we can do is actually, so we have two options. One is, I believe that siuba has a syntax that supports, rather than defining this function that just takes a single table, we can just do this. Let's see, did that work? With the open. Essentially what this says is, So now we just need to put this back in. So summarize jobs, gender. I think we do it like that. It's been quite a while. It's not a great sign, so dang, maybe I failed. Let's see. This? No? What is summarize jobs gender a pipe? Yes. Summarize, mutate. Oh, what we can do, I'm sorry, we can do something like this right now. This is a future syntax I want to add, but we can just do this without a starting argument. And this will just create. So just like when we had it down here, pasting it, when it doesn't take a data argument, it creates a pipe. So just to show you, like if I take these pieces out and I don't pass jobs gender to them in the pipe, and rather I just paste them in here. Shoot, let's do this. Notice that it creates a special tool called a pipeable, and that's how siuba allows this index, is through these pipeables. So it doesn't, because it didn't receive data yet, it knows, oh, I might be part of a pipe. This is pretty similar to how dplyr works. So Dave defined a function. Wait, I'm going to do it all in here. Dave defined a function here. He named it function, but he could have used Magrider syntax also and done just a period. Oh no, I should not. I should overwrite because we want to keep this one as the canonical. So rather than taking a function that takes table, he could have done dot pipe like this. So that's a pretty cool syntax. siuba does a similar thing. We probably need to set it up so you can do underscore like this, so it's analogous to piping, but right now it works even without taking a data, this underscore pipe. Yeah, that's a good reminder that I need to develop and think more strategically about that syntax. So this did something kind of funny when I black formatted it. It got rid of this these quotes. It didn't think we needed them. All right. So that's a little diversion into piping. You can do this if it doesn't take data. You can think of it as a function that can be added to a pipe, similar to if I just pasted these down below right here. All right, so let me go down now, and now I'm ready to use it. Great, so I just dropped it in, and it ran. So I need to stop upward. I'm doing a lot of upward inflecting, like I'm asking a series of weird questions, and I'm not sure why. So that's a weird meta detail I'm noticing. Just going to do this. So I put it in the parentheses. I black formatted it. Now I'm going to put underscores in front of things. And then here I'm going to put quotes. I thought about using quotes instead of this underscore in siuba, but I like having the syntax errors pop up really early. I'll probably do some with tab completion in the future too. Cool. Yeah, so that ran. It looks analogous, at least these labels. I think that from glancing at the plot before an R, I think they look pretty analogous. I know it's hard to see with all these labels. At least the gross pattern seems to match. All right, so we looked at the pipe a little bit. We broke down just for year 2016 wage gap or proportion that females are making as a proportion of of male wages in the census data. Let's see, so we can go to the next. Oh no, okay, so now they have Plotly. This is basically a little bit of interactivity. The really powerful thing about Plotly here is that in R, you could just use ggplot, and then Plotly has a special function that you can just say, now that I've made my plot in ggplot, just wave a magic wand and make it interactive. That's not something we can do here. So we can go, as far as making the plot, we can't do the interactivity. It'd be really cool to see in Python though. And there are other libraries for doing interactive visualization like Bokeh. I think Altair, I think, is another one. It's worth exploring maybe after this. Okay, so I'm going to put it again in parentheses. Oh, yep. Okay, and then I'm going to black format it. Oh, I can't. I think I have a... Yep, I left it a pipe. The reason I can't black format until I get the pipe right is because black needs to be able to parse the code, and that percentage sign greater than percentage sign is a syntax error. Okay, so then I'll replace these. The more I do this, the more tempted I am to make a hotkey that just replaces these with underscores. Okay, so, you know, a nice thing about plot9 is you can actually do this, so it knows to run this operation. Let's see, total earnings, total workers, occupation. I think that's it. We need to change this with a list. We might need to change even the word range. I can't remember. I think it's right. So this is where it uses percent format. I'll get to that in a second. Oop, we need to import the arrange function. Okay, great. Let's see how it stacks up. Oh, R. I also don't know. I'd be surprised if Plotly displays here. Yeah, we're gonna have to just print the plot out. So notice he's saving the plot to the name P, something we could do also, and then putting it here to dump it as cell output. All right, so this looks good. I think I'll have to loop back in another video and look at some of the plotting libraries for interactivity. The one thing left is to $ format and percentage format. I'm going to grab, I could try from memory to format in Python will be something like this. Percentage sign format will be like 0.2D or something, dot format. Let's see. Oh, that's not it at all. Oh, it needs to be inside. Sorry, like this. No? Maybe I just totally forgot how to format. Let me look back. I don't have these two well remembered, so I'm just going to open it as a text file, or maybe not. Let's see. Oh, that's bad sign. Uh-oh. Okay, so I'm going to search for this. No, keep going. Yeah, here. 0f. It's a float. Yeah, that was dumb of me. So what this does basically is if we take this, we're going to format this so that if it's 25, it will look like, that's not right. Oh, 25 times 100, it looks like 25%. All right, so let's copy that in. Percent format. He's using the scales package, I think, to do it. So, and we're gonna not, since percent format is a function, we can just pass it right in. So notice now that this has nice percentage formatting. Dollar format, I couldn't tell you. So let's see. I think it has commas. Yeah, I'd have to probably Google it. Let's see. Python format dollar amount commas. Or actually, it should just be commas. Format amount commas. Yes. I think we can just do. Oh, you can. Oh, that's convenient. You can just do a comma. So, oh, that's handy. What we can do is, so here we could do something like this exact thing. I'm gonna put double quotes around it. Well, black will make it work. So, and then we need to do dot format. I think. No, that was wrong. Oh, because it has to take a list. So we need something like this, where rather than dot format being on just the dot format, it actually needs to apply it to every value in a list. So I'm going to say dollar format, make this large. Oh, okay, where'd you go? Equals just comma and a dollar sign and no times 100. All right. And then dollar format. Cool. So it does have this 0. We could format that out. I think actually by converting it to a D. No, integer. Let's see. No, that's not. Oh, that's not going to work. So maybe we could do 0.0f again. Yeah, so that took out the 0.0. So that says to use no zeros after the decimal, but use the commas to separate every 3 zeros. So 1,000, million. All right, so now we're in business. Exit single document mode. So I pressed Command-Shift-D, and that returned to have these two side by side. All right, so we had to get rid of ggplotly. All right, we're on the last though, so I'm gonna take this out because we don't have ggplotly. I'm gonna put the pipe. Here's where ggplot starts. Looks okay, looks okay. Need to have a list here. This is the equivalent of what was happening in R. We're going to take out %format, use our custom lambda. I think that's it. So we did it. Nope, that was dumb of me. I'm going to black format it. Underscore. Yep, underscore. A downside of if we had used strings instead of this underscore syntax, we would have. It's kind of tough when you have strings in strings, I think, to get a quick sense for what's going on. We use negative in this family. For now, siuba might. I think siuba actually has implemented descending. All right. Now we're in plot 9, so I'm just gonna quote these here. Cool. I think that'll do it. Nice. Let's see if this is the same. Plot, take out plotly. Yeah, I'm curious. Maybe I'll have to look back and see how to just use the not ggplotly but the regular Python plotly library to do this. But this looks good. So this is percentage. This looks like percentage of total workers that are female. No. This seems wrong. sorry, that's x-axis. So this is, percentage. Oh, it's the median. The median female salary divided by the median male salary. I'm not sure he used the median. I'd have to check. It might actually be a formula that turns out to be the median. It's not the craziest thing. Color's the minor category, so that's architecture, computer, or life, physical, social science. And then the label. Oh, label is something used by Plotly, Gigi Plotly. So what would have happened is we would have been able to mouse over and it would have shown the name of the occupation. Total number of workers, percentage workforce, report as female. Okay, so this is the percentage of the workforce. This is the proportional salary for females. So you can see it looks like in architecture and engineering, smaller percentage of the workforce reported female. Computer mathematical starts to get higher. Life, physical, social science, much higher. This might be psychology or education. Actually, it could be a number of things, including like sociology. If they have social work in there, I wouldn't be surprised if it has a pretty high proportion. All right, so that's the translation. We made it through pretty quickly. We talked about some exciting features that siuba has, including that you can just save parts of the pipe to a variable, so you can reuse them really easily. We look quickly at the value of this filter versus drop NA. I think drop NA is great for most cases. It's just if you want to like invert and see the things you dropped, this can be really helpful. And I think that's basically it. So thanks for watching. Be sure to, if you're interested, to check out siuba. I'll keep pushing releases and try clarifying docs. There's already quite a bit of documentation, both on the README and in the siuba docs. If you have any questions, though, feel free to reach out either on siuba issues or on Twitter at Chow the Dog. I'm happy to answer things. I'm really curious about people's experiences with the library and continuing to improve and speed up the pace at which people could do analyses. All right, thanks for checking in.